Okay, 4,2 is equal to mass. I'm looking for the mass over molar mass. Then I need the molar mass for calcium nitrate. Calcium, we know it's 40, all right? Nitrogen, we know it's how much? 14. So it's going to be 40 plus 14 times 2 plus 16 times 3 times 2, which is 16 times 6. Are you following? Right, because there is a 3 here, so it's going to be 16 times 3. All right, 16 times 3. Then there's a 2 here. You also multiply that, so you multiply again by 2. So actually, you're multiplying. There are 6 oxygens here, so 16 times 6. Right, so your answer becomes 164. Please be careful with this one here. In terms of the number of atoms, especially the ones that are in brackets. Right, then your mass becomes 164 multiplied by 4,2. Your answer is 688,8 grams per mole. Becomes 688 grams per mole. Right. I cannot write here. 688,8. Sorry, not grams per mole, just grams. Sorry. Right, because it's mass. We're not looking for molar mass. We're looking for the mass. So that's what we have. Right. Marks here, we are using the same formula, so you're just going to get 2 marks. You're going to get to 2 marks. So here you've got 3 marks, 2 marks. You've got 1, 2, 3, 4. Right. So for this particular question here, you're going to get how many marks here? 5. Yeah. So here it's 5, and here we said how many here? You said 4. Here, and here we said 2. All right, the rest there, Ayabulela, can you add for me? It was out of? Okay, so let's add 8. Question number 1 was 8, yeah. Number 2, 19 for 1, 2. Everything is 19 now. Right, so please give a total out of 19. Everything is out of 19. Looks like it's yeah. Or question number is 19. Yeah. Also, so you added 1 and 2, it's 19. Okay, yeah, then it makes sense. Okay, so we're going to have 19 plus 2, that's 21. 21 plus 4, that's 25. 25 plus 5, 30. So please give a total out of 30. If you got 30 out of 30, you mark yourself there 30 out of 30. Right, so that's what we have for exercise 28. Exercise 28. That's what we have. All right. We have 28, and we've revised question exercise 27. Now, any questions, please? Question number 1, it was 3. It was just calculating molar mass, 1, 1, 1. So it was 3. So that yes, Zinedine.
Is the entire total out of 30 or just exercise 28?
Just exercise 28. Yeah? Okay. Or you added the whole 28 is 19. Also, you added with the exercise. No. Okay. No, my bad here. It's not 30. She says 19. 19. Exercise 28 must be out of 19, not 30.
Okay, sir.
Do you agree, Zinedine?
Yes, sir.
Okay. Right, fine. Let me clear here. All right, so we move on to today's lesson if there are no questions. All right, let me just open my activity for today. Let me just open this. Today we're looking at percentage composition. Percentage composition. That's what we're doing today. Percentage composition, right? and empirical formula. Percentage composition and empirical formula. That's today's lesson. Percentage composition and empirical formula. So we start. We look at percentage composition, right? So here, what do we mean by percentage composition? Simply, when you're given a substance or you're given a compound, you want to know what is the percentage of each element in that given compound, right? So I'm going to define it at the bottom here, but why do we need to know this? Knowing the composition of a substance can help us to find the formula of a substance. If we know the percentage of each and every element, then we're able to come up with a formula for that particular substance. Right? There are 4 different types of composition problems that we're going to be looking at. There are 4, but here I've just listed 3. The first one, problems where you will be given the formula of a substance and you're asked to calculate the percentage by mass of each and every element in the substance. Then the second type of problem is where you'll be given the percentage composition, then you have to calculate the formula. So these 2, you're going forward, then you're going backwards. So here, if you are given a formula, you can find the percentage of each element in that formula. If you are given the percentage of each substance, then you can find the formula. So this is back and forth. You're just going forward, then here it's the reverse of the other one. Then number 3, problems where you'll be given the product of a chemical reaction and asked to calculate the formula of one of the reactions. This is like your stoichiometry that you will be doing. So there's another 4th one. I just listed the 3rd one because this is what you need to know for now. We also have your percentage yield and so on that we'll have to do later on. All right, so let's look at this. The percentage composition, right, of a substance, right? It refers to the percentage of each element by mass that makes up that particular substance. That's percentage composition. Clear? Right. The way that this is calculated is to find the molar mass of the compound first. So we need the mass for the, what we need to find? We need to find the molar mass of the substance. Like let's say water. We need to find the molar mass of water, which is going to be hydrogen. There are 2, oxygen is 1. So it's going to be 1 times 2 to give you 2, plus oxygen, which is 16 to give you 18. That's the total mass. So you need to find the total mass. Then determine the mass contribution to this total mass by multiplying the number of atoms of an element by its relative atomic mass. So if I want to know the mass for hydrogen, what am I going to do? I'm going to say how many hydrogen atoms do I have in water? I've got 2. So it's going to be the mass of those 2 hydrogens over the total multiplied by 100. So then this must be expressed as a percentage total. I'll do an example for you to understand here. Example, calculating the percentage by mass of elements in a compound. So here we've got to calculate the percentage composition by mass of potassium sulfate. So we want to know what is the percentage of K in this whole formula. What is the percentage of S in this whole formula? What is the percentage of oxygen in this whole formula here? Is that understood? Right, so number 1, what do you do? A, you need to find the molar mass of the whole substance. So this is what we've been doing, molar mass. So you're going to go on your periodic table and you calculate the molar mass for, you check the molar mass for potassium, you find it's 39. Other sources, they round it off to 1 decimal place, so you get 39.1. How many are they in the formula? There are 2, so you multiply by 2. Plus sulfur is 32.1. Plus oxygen, 16. But how many are they? 4. 16 times 4. You add that, you get your answer to be 174.3 grams per mole. Are you following? That's our molar mass. Right. Now, I want the percentage for potassium. That is K. So percentage of potassium, I'm just going to look, how many potassium do I have? 2. What is the mass of each? 39. Right? We're supposed to put our 39.1 here so that it's consistent here. But here there's a 39. But anyway, it's fine. So we're going to have 2 times 39 divided by the total mass, which is that total that I have there. Is that clear? All right. 174,3 multiplied by 100 over 1. Then my answer becomes 44,83%. So this becomes the percentage of potassium. Is that clear? Right. I'm not done. I go again, I do sulfur. So I do the percentage of sulfur. Percentage of sulfur is going to be, what is the mass of sulfur? It's 32. How many sulfur, how many sulfur atoms do I have, or elements do I have here? I've got only one. So it's just going to be 32 over my total, which is 174,3 multiplied by 100. Then my answer becomes 18,39%. I go again, I'm not done. I go to oxygen. I check what is the molar mass for oxygen. It's 16, but how many are they? 4. So I do that again. Percentage of oxygen is going to be 4 times 16 divided by my total multiplied by 100. I have to convert this to a percentage. My answer becomes 36,78%. Is that clear? Right, that's all that I've done here. So you do for all the elements that make up that particular substance. Clear? Right. Can you do this one for me? Calculate the percentage that each element contributes to the overall mass for sulfuric acid. Can you do H2SO4 for me? I'll give you 3 minutes. Can you calculate the percentage composition of H2SO4? Everyone, use your periodic table. 3 minutes. Yes, Rohan. Rohan? I think today is day 5. We have got physical science around about, it's not, I think it's our period 7 and 8.
Day 5, sir.
Yes, it's day 5 today.
They should be now, sir.
It should be now.
Yes, sir.
On day 5, let me double check. Day 5. Is it day 5? Day 5. Oh, it's supposed to be now. Okay. All right. But the lesson is supposed to start what time? 25 after 9. Yeah,
No
it's
idea, sir.
yeah, it's day. It's a period. Period 3 and 4. So we're gonna have it 25 past 9. Join at 25 past 9. I need to finish up this lesson with the grade 10s.
All right, sir. Thank you.
All right, sure. You want the periodic table? Okay, which substance you want? Hydrogen is given there. Sulfur, there is sulfur 32. Oxygen is 16. Okay. Right, okay, your time is up. Let's have a look. What is happening there? Let's just read it here. Right, for H2SO4, right, what is the molar mass that you found here? It's 98. Did you get 98? Right, so your molar mass is going to be 98. Then percentage of hydrogen, what is it going to be? It's going to be 2 over 98. 2 over 98 multiplied by 100, isn't it? What do you get? Huh? Right, it's going to be, how much is it? 2,04. Right, then the next one, sulfur, is going to be 32 over 98, isn't it? What is the percentage, sulfur? Huh? Yeah, final answer. 32.65%. 32.65%. Right, then the last one is your oxygen. Oxygen, what is it? 65? 65.31%. Right, so those are the answers that you get if you did it correctly. Right, any questions on this one? I think it's straightforward, right? Okay, we've got about 10 minutes left or 8 minutes left. Let's look at the last part of this question here, of this handout here. If they are grade 11 in this class, please, we're gonna have our class at around about 25 past 9. That's period 3 and 4, not now. No? Grade 11, you can please go out, then you come back at 25 past. Right, okay. Let's look at the empirical formula. Empirical formula. What is the empirical formula? All right. This grade 11, they're joining, like, I don't know. Yeah, but the time is not now. Grade 11, please, can you join at 25 past? 25 past, Lufuno. 25 past, please, not now. I'm still with the grade 10s. Okay, let's look at the empirical formula. The empirical formula is the chemical formula showing the simplest ratio in which atoms are present in a compound. The ratio is a whole number ratio. So what is an empirical formula? Is the simplest whole number ratio of atoms in a compound. Are we together? Please, can you write that definition for me? Okay, you're gonna write empirical formula. It is a whole number. It is the simplest whole number ratio. It is the simplest whole number ratio of atoms present in a compound. It is a whole number. It is the simplest whole number ratio. It is the simplest whole number ratio of atoms present in a compound, or whole number ratio, or simplest whole number ratio of atoms in a compound. Clear? Right, that's empirical formula. The empirical formula can be calculated from the percentage composition of a compound, right, from the masses of each element present in a sample of compound. So you can use percentage or you can use masses to calculate the number of moles. Then you do the empirical formula. I'll show you now. The ratio of atoms of each element is a mole ratio. So basically, we are calculating the number of moles. Then we use them as a ratio to determine the formula. So so to get empirical formula first, we need to find the number of moles of each element present. Right, let's look at an example. A compound is got the following percentage makeup. So you've got potassium. Now these percentages, those percentages that we got in the previous activity, where you are calculating percentage composition. Clear? Right, so potassium, what is the ratio here? 38.61%. Oxygen, 47.52%. Nitrogen, 13.86%. Clear? Determine the compound's empirical formula. So what are we going to do? First, we're going to calculate the number of moles. All right, so you're going to do your number of moles. So what are we going to say? We're going to say number of moles is mass over molar mass. But the mass that we're given here, we're given it as a percentage. So we're going to take that percentage to be our mass. So our mass, our percentage is going to act as our mass. Is that understood? There's no need for you to convert this percentage again to mass. Do you understand what I'm saying? You can just take that to be your mass. Right. So you're going to take that mass over molar mass. So what is the molar mass for potassium? It's going to be 39. All right. Or if you like, you can just write it as a ratio straight away. You can just write on top here, I'm going to write K is to oxygen is to nitrogen. Then at the bottom, I write my 39.61 divide by 39 is to 47. I can just do it as a ratio all the way. 52. But I must just know here I'm using my I'm using number of moles over molar mass. I'm using this number of moles is equal to mass over molar mass.
So,
That's what I'm using. Yes, Zinedine.
so I can't see what you're writing clearly, sir. Maybe it's the pen color or something,
Or the
but I
pen
can't see
color.
what you're writing clearly.
Okay, let me try red. Then I'm going to use 13. Is that better?
Yeah, thanks, sir.
Okay. Over 14. I'm just repeating what I have, but here I'm writing it horizontally as a ratio. You see the dots there? That's your ratio.
Yeah.
Yeah. If you don't like to write it like going down like this, you can just write it as a ratio. Then after that, I get my answer. My answer here is going to be 0.99. 0.99. We've got 10 minutes left. Okay. No, I can't close this. Okay. I hope I'm recording this. Yes. Okay. Right, so I'm going to have my 0.99. That is 0, guys. I think you can see my 0. And another 9 is 2. The next answer that I get when I divide 47.52 divided by 16, I get my 2.97. Then when I divide 13.86 divided by this, I get 0.99. Then what do? I check which one is the smallest number here. I've got 0.99, 2.97. My smallest number, what is it? 0.99. So I'm going to divide everything by the smallest number, which is 0.99. So I'm going to divide here by 0.99. I divide this one as well, 0.99. I divide again this one by 0.99. Then I check 0.99 divided by 0.99, the answer is 1. Then I've got 2,97 divided by 0,99. What is my answer? Yeah, it's 3. They're not going to come like straight whole numbers like this. Maybe you get 2,97, then you must round it off to the nearest whole number. Or 1,01, then you round it off to the nearest whole number. Then I divide again here. 0,99 divided by 0,99, my answer is 1. All right. So the ratio here is 1:3:1. So my formula, my final part, the formula is going to be, so it means K is 1. So my formula is going to be K. And my O is 3. So my formula is going to be O3. Then my N is, my N here is going to be 1. So it's N. But this does not look familiar. So it means here I have to write them according to the order on the periodic table. You write it according to the order on the periodic table. If you check which one appears first from your left to your right, which one appears first? K is in group 1. So I'm supposed to have written it with K first because it's in group 1, followed by nitrogen, which is in group 15. So I'm going to have N. Then oxygen is in group 16. So I'm going to have KNO3. That looks familiar now, isn't it? Right, so the name of this substance becomes your potassium nitrate, KNO3. That's how you determine the formula if you're given the percentages here. Is that clear? Right, okay. So that's how you do your empirical formula, all right? That's how you determine your empirical formula. Any questions? Any questions? Any questions? So the rest here, you can just follow that. It's still the same thing. We come here 131, then the empirical formula becomes KNO3. Remember that when we write chemical formula, the order of elements is as they occur from left to right on the periodic table. Clear? Right. There's another example. There's another example that I'm supposed to look at, but because of time, I won't look at empirical formula and molecular formula. So what I'm going to do, I'm going to pack this one now. Then I will continue with this on Monday. But there's an activity for you. Yes, Joshua?
Sir, can you do another example of the same thing?
Of the same thing. But my time is up. You know what we're going to do? I'll check during your other period with 10Y. I'll check how if you are not busy with another subject, then I can always ask you to join again so that I can explain. I don't know if it is fine. Because I have to see.
Yes, sir, it's okay.
I have to see the grade 11. I'm going to post this. There's another example that is here. You can use this example here. There's another example. You can have a look at this. Just try and check this. Right? If you don't understand, then I will explain it maybe in the second in the other period for 10Y. Is it 10Y?
Okay, sir.
Yeah.
Yes, sir.
But otherwise, just send me a message. Then I will explain for you. Right.
Okay, thank you, sir.
Okay, here I've put exercise 29. So please, can you do this one here? Try and do this. Wherever you find molecular mass like number 4, leave out number 4 because I have to explain that one. You can leave out number 4, but you can do 1, 2, and 3. Is that clear?
Okay, sir. Yes, sir.
Google Classroom, then you do that. Right? Okay. Enjoy your weekend.
Same to you, sir.
Bye.
Bye.